Hello everybody, and welcome back to another Liberation Circuit video. Today I'm going to talk about the stability object. In my last video I unlocked it in this region, but I want to show you how powerful it can be. So first I want to show you what I actually want to do with the stability object. So we're going to go to purple 3 here. This is a very good example of the use of stability. So here's the enemy. I want to talk about this process. So this thing has stability on a few components. There's one here, 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 and here. So that's 6 stability, and it's on all of the outer process, the outer components on the process. So this process is pretty strong. It does something unique, and we are going to want to copy it. But first I need to show you exactly what it does. So I'm going to play through this a little bit. I'll be back when I see one of those processes. Okay, so right here we have one of those processes. It is getting shot from the back. This is exactly what I want to show, but so basically all of these stabilities are turned off. You can see that they're off in the notation here. So we're going to see what happens when it gets shot. Okay, so these components with stability on them got shot, and they just automatically turned on. So all of these ones that are off are not using power, and these ones that are on are using power. So basically this thing is getting double interface but without using all of the power that stability requires. So we want to emulate this in our process, but let's just see who wins this fight. I think it'll be my guy. It'll be kind of close. Yeah, he died. But yeah, so I'm not going to beat this level today, but I just wanted to show that. So, hold on. I wanted to show something else. Let's look at so this is one way that you can get ideas for how to make your processes. So, as you can see, we can actually see all of the code that makes this thing work. So, right off the bat in the header, we see that this thing has got a bunch of classes for stability. When you autocode a process, it'll just make one class for stability and then turn it on. That's going to make it use a lot of power though, so I don't want to do that. So let's take a look. We're going to search for when this stability 1 here is being mentioned somewhere else in the code. I can't paste it. Oh, it's awful. Stability 1. Recycle that. F3. Okay. So we have in the header, here's the auto stability class I was talking about, but it's also being referenced as stability 1. So I think this is the only instance that will see stability 1 in the header. So yeah, here's stability 11, 12, 14. So yeah, we only got stability 1 once. So that means it refers to only one of these stability objects. Okay. Now let's take a look. So we got to this point in the code. We have stability 1. Okay, so this will turn on and off the stability. Let's check. Okay, so component hit time here, cycles. Let's see what these are from. Okay, so this is referencing component 1. I think this is what stability 1 means. It's the stability on component 1. So it's probably like this one or this one, I'm not sure. Oh yeah, it's this one. Select component 1. This is component 1 right here. So whenever this component gets hit, that's what this is saying. We are going to set an array that has component hit time. It's going to be equal to cycles plus stability time. So what is cycles? Let me see. Okay, stability time is 20. It's good to know. Just search. Cycles. Can you find it? Okay, cycles, it just goes up by 1 every single cycle. So this is a counter for how many cycles we've got. So basically so we're setting the component hit time to the cycles plus stability time. So that's good to know. And then okay, so this is a timer. So it's getting set to the cycles plus the stability time, which is the time it basically means the time that that the stability on this object is getting turned off. So if component hit time is greater than cycles, so when cycles catches up to this will be, the stability will turn off. But if it is hit, it will turn on. So that's why this stability stays on. So yeah, I hope that makes sense. So basically here, if the component gets hit, we're going to set a timer. That timer is going, this is going to basically say the last time that the, okay, I need to think about how to explain this. So this will set, if the component gets hit, the time at which the stability will turn off will be set. And then once the cycles variable catches up to that, it will turn off. But while it's not caught up, it'll stay on. So that'll make it turn on for 5 seconds, I believe. 20 cycles. And that works for every single component. Okay. That's basically what I wanted to say. We're going to apply this to our defender here. I want this thing to have stability. So it already has 12,000 interface, which is a lot, but I want it to be more powerful. So we're going to put stability on this as well. Yeah, so I believe I need to explain classes and the header first more. So I already told you that the header was what described what the process looks like, but there's a little bit more to it. So these classes up here, this is how you refer to stuff in the header. So let's find something. Okay, so we have pulses here. So these are facing different directions. This auto attack or auto ATT right and auto ATT forward, these are basically directional attack classes. So whenever we want to attack forward, this class will be attacked. We'll call a method on this class, and it's full of a group of pulses that are just facing towards the front. This right header button will do this, make this header automatically for us, so you don't have to worry usually. Then there's auto attack right, auto attack left, stuff like that. You might notice though that the interface objects do not have a class. So yeah, these guys, all of these here, they don't have a class. These are called on as a whole group. So whenever you have an interface on your process and you call a method to charge the interface, it always refers to all of the interface objects. So you don't have to worry about calling a class. But things like this auto attack and pulse XL, things like that, you need to call them as a class because that'll determine which ones will actually fire when you call the method. And that's how the other process differentiated between all of the stabilities. So when we do this, we're going to have to write our own stability classes. But there's a little bit of a catch here. So you can only have 16 classes on your process. So we're going to have to make sure that our design supports 16 classes. Right now we got these things that are kind of sticking out the side here. And if we want to make a class for them, or if we want to make a class for all the stability, it'll be way more than 16. So I'm going to have to redesign this process to make sure that the outside components will have stability, but we don't have so many outside components that we have too much components that need stability. So it's going to be a little bit of a design change. So I'll do that real quick. I'll be back. All right, I'm back. I probably went a little bit overboard with this one, but it's okay. This thing still has 12,000 interface, but now all of these components have stability. This one does not though, and even though it's kind of open to the outside, so keep in mind that you don't need to put stability on every single component. These two are they're pretty close to being covered, so we're not putting stability on them. And then, of course, the core is pretty protected, so we don't need stability there either. One thing that I did also add was this thing. This thing is just a core with a bunch of pulse XL on it. This actually fits right into this slot here. I spent a little bit designing that. I've never done something like this before. I thought it'd be fun, so I did it. There is some code here that under the initialization that just adds it to the build queue. It should build first thing once this thing is done building. So it'll make it'll use these very specific values to put down that core. I got all of these numbers just from trial and error. I figured out where the core would go first, and then I put components onto the core and eventually designed something that would fit perfectly. So I guess I could show you that really quickly. Let's go here. So this thing gets built first, of course. Okay, it's building. When it's done building, it builds this thing. This thing will just shoot at everything that comes near this. And of course this power is independent of the power that this takes, so this thing won't run out of power if this thing is trying to charge its interface way too much. So yeah, we might switch out some of... This thing just has pulses on it right now. Later we might put some different weapons on there, depending on how I'm feeling, but this is basically just, yeah. This is just a fun little thing that I made. I thought would be cool. Okay. Now that that's done, let's go to the main thing. We want to make the stability on this thing work. So usually when you have stability on your process, it'll just make it so that the stability just stays on all of the time, which of course uses a bunch of power. We don't want it to use so much power though, so we are going to change it. Okay. The first thing you need to do when doing this is make sure that your components are numbered correctly. So sometimes the right header function, it'll mess up the number on these components. So the first component, it's basically always in the order of how they appear in this list. So this component will be component 1. The core is component 0, by the way. This is component 2, 3, 4, okay, 5, so on. So if we find something that's out of order, we're just going to change it. Okay, so nothing was out of order, so we should be fine to just leave it how it is. Now we need to put down a bunch of stabilities. So I'm going to delete the default stability class. We don't need it. Then I'm going to delete all of these other classes here. If you notice the comment, it just says that these classes aren't being used for anything. So I can just delete them and it won't break anything. Okay, so we're gonna have class stab1. This thing has 1, 2, 3. This thing has 12 stability on it, so that'll perfectly fit the number of classes that we have available, I believe. And I'm not going to actually name the classes anything very specific. I'm just going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Tried compiling it. It doesn't work, of course, because we removed the auto stability class, so it'll be here. So we're gonna have auto stab. Wait, no, we don't want auto. We're just gonna have stab1 for our first stability. So once you assign a stability like that, you will make a comment just so that you remember which component it's attached to. So this is component 4, since we just put it on the fourth component. This one will be, here's stab 2, so that'll be on component 5. There's something else I want to show you here. Right here, we have a kind of interesting stability object. It's pretty far away from anything else that indicates where a component might be. So you might say this is component 5, but that's wrong. We need to keep track of the indentation as well. So component long 4 here, it has all of these other components that are linked to it. So everything above this belongs to that long 4 that we just looked at. It's all attached to it. So it's one of these central ones here. So basically, this stability right here, you can take a look. It belongs to whichever has the correct indentation. So this long 4 right here, component 3, that's where the stability belongs. I just wanted to point that out. I'll keep doing this. Alright, so I've assigned all of these classes to various stability objects. Make sure that before you do this, this process design is the one that you want to keep. Because if you don't want to keep it, you'll have to overwrite the header when you redesign it, and that'll delete all of these classes that you set up. So yeah, worry about that. Okay, so the next thing we want to do is make sure that these classes can be attached to their components. So what I'm going to do is I'm going to write a little indicator. This is my way of implementing this. The way that the AI implemented this is it just had a bunch of if statements, if you remember correctly. I don't like if statements like that, so I'm going to make a loop to do it. But in order to do that, I have to do a few other things first to prepare the code for that. So I'm going to say this is class 0, 1, 2, 3. So this is class 4 through 15, I believe. So now that we have that in mind, we are going to go down and we're going to make an array. It's just going to be in the initialize. This is going to be like a dictionary, kind of. We're going to basically say that certain stability classes belong to components. So we're going to make a new integer. How can I do that? Okay. Int stab component. So we're going to have 12 entries in this array, one for each component. Okay, so stab component 0 will be equal to the component that stability or the stab 1 class belongs to, so component 4. I'm going to set this to 4. And then we're going to set the next one to, we're going to set stab component 1 to whatever the next one is, so 5. And we're going to do that until we assign all of these. So I'll be right back when I finish doing that. Okay, now I've done that. I forgot to add colons. I should probably do that. Okay, now that that's done, the next thing that needs to get done is we need to make sure that I can actually do that. So let's first set up a timer. We need an int cycles here, just like before. Cycles plus plus. So every single cycle, or every time this code is run, this cycles variable will just go up by 1. And then we're going to have an enumerator, like before. And then we're going to have stab time equals to 20. So this is going to be the amount of time that the stability is on for. You can make it higher or lower depending on what you like, but I think that 20 is a very good number of cycles for it to be on. So that's 5 seconds. Okay. I should put this. I'm messing it up. Yeah, need a colon there too. Okay. So now that that's done, let's go down and make sure that the stability can turn on. So there's something else I want to also talk about. There's a few resources in the game. You know about data, you know about power, and you know about, yeah, I guess that's it, data and power. So there's another resource. It's called instructions. This number here. So each core has a certain amount of instructions that they provide. This particular core is the maximum number. But basically, whenever you run a piece of code, it'll take some amount of instructions to run the code. So basically, if you go over that number of instructions, the code just stops running. And you don't want that because then it might not do certain things. So if it stopped running before it got to this attack scan, for example, then this process wouldn't fire it in. So basically, I'm going to put this stuff at the bottom because if I put it at the top, then there might be a chance of the stuff at the bottom here not running. So I want it at the bottom. I'm going to go ahead and do that then. So we're going to have, oh yeah, there's another thing you can do as well. So when you refer to a class, usually you refer to it by name, like stab1 here. So if I wanted to turn on the stability, I'd say set stability 1. You can also refer to this class as an array. So this is also class, and then I believe this is 4. Yeah, class 4. Set stability 1. So you can also do this. This will also set the same stability to on. Okay. Those things in mind, let's now make our loop. So we'll have an int I first. For I equals 0. I is less than 12. So there's 12 components that we need to turn on this, or check for turning on stability. And then I plus plus. Okay. So first thing I'm going to do is I'm going to check a component. So I want component, and then here's where our list comes into play. This stab component list. Wait, also it's an enum, so we should capital. Stab tab. Okay. The stab component array here. So we're gonna, this is where it comes into play. Stab component, and then I. This allows us to indicate which component we want to refer to and say get component hit. So this will tell us if the component has been hit or not. So I want to say if this component is hit, we are going to set a timer for stability. Okay, we need a new array for that actually. So we're going to have int timer 12. Int timer 12. This will be our timer for stability. So if that component is hit, timer I will be set to cycles plus stab timer, or stab time, I believe it's called. Forget. Let me check again. Stab time 20. Stab time. Okay. So this will turn on the stability for some time. Well, it won't do that. It'll turn on. It'll set the timer to the time that we want to turn it off. So class, we also want to turn it on though. So class I plus 4 because we want to refer to the fourth class when we're referring to the 0 class. And then when we get to the I equals 11 case, we'll refer to the 15th class as well. Dot set stability, and we're going to say 1. 1. Okay, so this should turn off the stability whenever a component gets hit. Now, we also want to figure out if the timer for a particular stability is gone by. So if timer I is greater than or less than cycles, actually no, we want greater than. This will make sure, if we typed greater than, then it'll, wait, what do I want? I don't know what I want. We're just going to do this for now and see what happens. We need to, if the timer is less than cycles, which means that the time has gone up, we want class I to have stability turned off. Okay, so this should do it, but I'm kind of worried about how much instructions this will use. Let's just give it a go. Okay, it's building. It's using 800 instructions right now. It's not too bad, but once it gets shot, it can probably be a little different. I'm also going to send this builder here away so that it doesn't interfere too much. Just going to go up there. And then go up there. I really just want this thing to be hit. It turned on. Will turn off. don't think it's turning off. Let's take a look. It's very rare to get this right on the first try. So, yeah. Okay, so I was setting class I. It should be class I plus 4, like before. Let's give it a go again. Let's try a harder level though, so that maybe gets hit more often. This one. I just want something to pop by and turn it on. And then see if it turns off after. Okay, looks like the right ones have turned on. I'm using shot, not using too much power. So far so good. That one turned off. Let's see if the rest will turn off after this is over. That one turned off, this turned off. And let's wait for these to turn off as well. Okay, looks like it works. I'm gonna just do it again to check the instruction count though. Make sure we're not going over too much. Because I still want to do more with this process in the future, I believe. Okay, the instruction use definitely went up, but not quite too much. So, I think there won't be a problem here. Maybe in the future it'll change, but for now this is absolutely perfect. It does exactly what I want it to. So, there you go. That's how you make stability on a process like this. It will be very, very powerful in the future. So that's it for this video. I'll catch you guys next time. Goodbye.